Hello, I am Dr. Deepthi and we are looking at different concepts from mathematics under the heading Decreations Mathematics, and we have been looking at complex analysis. Now today let us look at some solved problems on the basis of Cauchy's theorem. So the question is that you have to apply this Cauchy's theorem to evaluate a certain integral defined over a closed contour C, and the functions have also been defined and C has also been defined. So C is a positively oriented unit circle. That means mod of Z is going to be 1. And functions are, the first function is Z square upon Z minus 3 and the next function is log of 1 plus Z. So what is Cauchy's theorem? Let us recall that if f of z is an analytic function in a simply connected region D, then this integral of f of z dz over closed contour C is 0, where this particular contour is contained in D. Now, let us look at the questions. In the first case, f of z is z square upon z minus 3. Now, when you say that a function is not analytic, we first look at the denominator. Now here you will see that the denominator will become 0 only for the situation where z will be 3. That means this function will not be analytic for z is equal to 3. But now we have to pay attention to what contour has been specified. So the contour is basically the unit circle. That means mod of z is 1. So if you consider this point z is equal to 3, it is not going to lie inside or on C. In fact, it is going to lie outside C. So even if this function is not analytic at z is equal to 3, since it lies outside C, our condition for Cauchy's theorem, which is that f of z is an analytic function at all points inside and on the closed curve C, is still satisfied. So directly we are able to note the answer to be 0. So understand that you have to be particular about what contour has been defined. Only then you can decide how you can use Cauchy's theorem. So note this point. Now in case of second question, f of z is defined to be log of 1 plus z. Note that it's capital L. So we are looking at the principal branch. So again, Cauchy's theorem condition that the integrand here, it's analytic inside C and hence f of z has to be equal to 0. So answer is 0 even in this case. So we considered the problems where integrand was basically analytic inside C. Now in some future videos, we'll look at functions where the singularity is found to be inside C. So in that case, we will have to evaluate residue and then solve the integral. Thank you.